Hello all, today we are solving LeetCode problem number 2943, maximize area of square hole in the grid. So we are given two integers m and n, right? And we are given two integer array as well, which is h bars and v bars. And the grid has n plus 2 horizontal bars and m plus 2 vertical bars. So we have seen here that we are given only m and n, which represents the bars, and how can there be n plus 2 horizontal bars and m plus 2 vertical bars, right? So this m and n represents that internal bars basically. So let us have m, which is vertical, as 3 and n as 2. So we have 2. So this is what it represents. So how come we can say that it forms a grid? Only by having the border bars available, right? So that is the reason we have two vertical bars and two horizontal bars to finish the grid. So that is why we are given this particular statement here, and we have 1 cross 1 unit cells in the grid, right? And we are allowed to remove some of the bars from h bars and v bars respectively, and we cannot remove other bars which are not mentioned in these two arrays, right? So the output is to return the maximum area of the square shaped hole in the grid, removing all possible bars. So this is what we are asked to return. So which means if we are asked to remove certain bars, for example, we can remove this bar and this, and from this is from the vertical, and this one and this one from the horizontal. So from this we can say that we are getting a square, right? This particular forms a square, which is a square hole, and this is a maximum square hole. We can also say we can form this one as a square, and the 2 as a square also. This is a 3 cross 3 square. So as a result we can say that this is a maximum area, so we will be returning this, right? So let us understand this further by solving the example 1, right? So we have the example 1 here. Let me change the color of my pen. Yeah, so we have ns2 and ms1, right? So because of that we are getting ns2, right, and ms1, and the n plus 2 and m plus 2. Because of that we are getting the grid, and we have h bars as 2 and 3, which means we can remove 2 and 3, right? And v bars we can remove only 2, because only 2 is anyway 2 is there, we can remove only 2. So as a result, we are, for in case if we are removing the vertical bar 2, right, and we are removing the horizontal bar 2, which will result in this particular grid. And here we can say that this forms the maximum area, which is 4, and that is what we are returning here, right? And similarly we can say that if we are keeping this instead and removing this, right, so here also this forms a square. So whatever no matter whatever h bars we are removing, it forms a square in this problem. So let us understand with going through another problem, right? Sorry. So we can consider a grid which n is equal to 3 and m is equal to 2. So where n is a horizontal one, right? So 1 2 3, and m is a vertical one, 1 2, right? So sorry for my drawing. Okay, so this is the grid, and we are given h bars as we can have 2 3 and horizontal right row, we can mark this first. So 1 2 3 4 5 2 3 4, right? So horizontal we can have 3 4, right? So 2 3 4, yeah, this is fine. And vertical v bars we can have, for example, we can just have removing 2, right? So not true, I think we can go with 2 and 3, because this will be the similar example which we saw in the first one, right? So because of that, let this be the case. And from this we can say that if we can, by looking into this itself, we can say that the uh, biggest square which we can form here is this particular one, right? So this particular one can be the biggest square, right? Because we are allowed to remove 2 3, right? So this will disappear and this will disappear, and here also we can remove 2 3, this will disappear and this will disappear, and hence resulting in this big giant square. So other than that, there is no big square which we can remove, I mean which we can uh, remove the bars to get the maximum area, right? So what are the observation we can note from this particular example? We can, the uh, naive or the first observation which will come into our mind is, we can say that these two are same and these two bars are same, and hence resulting in the removal of this, right? So same bars removal, and this I'm just trying to explain the observation whichever we can get from this example. And if you observe deeply, there is a streak going on here, right? So this is 2, and this is 2 plus 1 increment by 1, and this is 3, right? And increment by 1, this is 4, right? So there is a grass streak going on here. So streak in the v bars. Similarly here 2 and 3, there's a streak v bars and h bars, right? So here we can say that the streak is 3 and the streak here is 2. The area is 2 here, and from this we can come to a conclusion that minimum of streak among h bars and v bars, right? We will be getting a side. So to find side, it's minimum of streak of h and v, I mean streak of vertical bar. So this is what we will be getting the side, and side cross side or side cross side is equal to the area. So this is what we need. So this is the observation we are getting, and this is the approach we are following to get code it up and to come up with the answer. And also we need to sort this, so we will be using this sort function to sort this particular h bar and v bar, and because of that the time complexity will be for h bar we can have it as it can be n log n, right? And this can be m log m, right? So in total it will be n log n, right? Or m plus n log n plus m, right? So this is the time complexity, and there is no space, extra space we are using, so space complexity will be order big O of 1. That is it, right? So with all this observation, let us go ahead and code this up, right? So we have to define a function which will calculate the streak, right? So long streak. And here we have to pass the bars, and now we can start by sorting the bars. So h bars sort, and the next one is v bars dot sort. Now we have to calculate the long streak actually, so we can have it as h streak is equal to long streak and pass in this bars. So h bars, right, h bars and v streak is equal to long streak b bars, and now we have to find the side, right? So side is equal to minimum among these two, so h streak and v streak. Okay, right? Yep. And now return side cross side, which is the area, right? And now we can go ahead and define this. So first we need two things actually, which is best streak to track the best. So this should be assigned to 1, because eventually no matter what, we will have the streak as 1, because each square is 1 cross 1 unit cells, so even that is a square, and the minimum among everything will be 1. So because of that, that will be 1. And current streak, so that should be also 1 for the similar reason. And since we told that the bars are indexed starting from 1, right? So we are we have to iterate through the bars first. So for I in range, we have to find if the streak is there, right? So because of that, we need to use I plus 1. So because of that, we will be iterating till a length of bars minus 1, right? So, and if bars of I plus 1 is equal to no, this should be equal to 1, right? So bars of I plus 1 minus bars of I should be equal to 1, right? If that is true, then current streak will be incremented plus or equal to 1, right? And else you start the current streak from 1. So current streak is equal to 1, because the streak stopped there, right? So and it starts from 1 again. So here you have to calculate the best streak. So is equal to maximum among these best streak and current streak, right? So current streak and best streaks, right? So now we have to return it, right? So right, yeah. And yeah, so while returning, this should be plus 1, because of this one, the bars are indexed starting from 1, right? So because of this reason, we are returning, because we are processing by 0 index only here. So because of that, we have to add 1 and then return it, right? So yeah, oops, I found a typo here. So let me go ahead and submit this. And this is an efficient solution. Thank you.